Welcome, everybody, to our third workshop as part of the CTE Momentum Your Place in Space Challenge. And this evening, we have a special guest with us, Bjarke Gotfredsen. Bjarke is one of our co-founders in MaxIQ Space, and originally he is actually a software engineer. But Bjarke has always had this skill, or should we call it superpower, of identifying technologies as they are coming over the horizon. And Bjarke has put together a number of his thoughts and ideas and a lot of research on the topic that we are covering today: space robotics and automation, machines in microgravity, or gravity less than 1G, as we have here on Earth. So Bjarke, what I would like to do is I'd like to hand over to you in a few minutes. If you wouldn't mind, I'd just like to cover our agenda. So what we have is an introduction to the challenge itself and the role of MaxIQ Space. Bjarke will give his presentation. Bjarke, if it's okay, what I'll do is, let's say every 5 or so minutes, if I could interrupt you, we're probably going to have some questions along the way, etc. We'll have we'll budget for a Q&A session after your talk, and then to have a look as well at how we're going to apply what we've learned. And then if there are any questions for the challenge team, the deadline for submissions is looming. So I'm sure that there are some questions in terms of those submissions for the CTE challenge. So just to briefly introduce the challenge this year is the first in the CTE Momentum series of challenges. And this revolves around Your Place in Space Challenge. And the idea this year is to develop a product or a service that is going to be extremely valuable and job creating in the future space economy. And that is why we're looking at a number of these different topics to actually see how can we apply business, product and service models to the industry. The role of MaxIQ Space, we have volunteered a lot of our experts' time and mentorship to the program. And on the recommendation of the CTE Momentum team, we felt it would be a good idea to actually have some of these sessions before the deadline to assist with that ideation process. So I think with that, Bjarke, if I may hand over to you, I'm going to stop sharing so that you can then share your screen.
Thank you very much, Judy. Let me get there. Okay, so I assume you can see the screen from my presentation. Judy, please just. Yes. Okay, that's great. Thank you very much. So I'm going to talk about robots in space, and I'm going to talk about it from a perspective of human versus robots in space, because we have a long history of sending humans to space. We kind of like stopped doing that, and what is the reason for that? And I want to talk a little bit about what is a robot. Everybody thinks a robot, and a fun fact is here in South Africa, we call a traffic light a robot. So it's not a robot, but what is it? And we're talking about that. And then I'm going to talk a little bit about building another celestial body. I might not go through the whole part of this thing, especially because the next session is about building on another celestial body or something like that, if I am being told correctly. So let's see how far we get with this presentation here. So I want to start with the Opportunity rover here, just as an example of a robot in space. So one of the things that was very nice about this specific rover was that it lasted 13 years, from 2004 to 2018. and it was planned to only last 3 months. It stopped working because the solar panels was covered from a sandstorm. And when you go through this presentation, I want you to think about how long it worked, this 2004 to 2018, and also why it stopped working. The fact that the solar panels didn't work anymore. It wasn't because of a mechanical failure. It simply ran out of juice. It couldn't operate because the panels was covered with dust. NASA hoped that the following year, 2019, there'll be a big storm that will come and clear that, but we never heard back from it, so it's probably covered. So with that, I want to kind of like start with this like very busy slide here, and there's gonna be a couple of video clips that illustrates my point here. So I want to talk about the conditions, human versus robots. And I'm now haven't defined a robot yet, so you can think about a robot like this robot arm or the rover or whatever you can imagine. For this particular thing here, it doesn't matter, especially how we define a robot. So there's a lot of different parameters we have to look into. So I have listed a long list here: air, temperature, water, etc., down to electricity. And then I'm going to talk about them from a perspective of different places. So let's start with a planet we know, Earth. So one of the things is that we have air, temperature, water, food, because the Earth is have this Van Allen belt that's like 3 times further away than the International Space Station. We don't have a radiation. We do have weather. And of course, we want weather because that is the thing that creates air, temperature, food, weather, and so on. So food and water and the other things they needed. But our problem is that we can't all the time predict what's going to happen with the weather. So we are in a situation from time to time where the weather is creating havoc. And that particular part is being influential later on. We have things that we take for granted, like, as I mentioned, that we don't have radiation, that we have light, that we have gravity of 1G, the pressure is fine out here, and the soil is still there, and things like that. So there's a number of things we don't think about, but which is also going to be a problem once we get away from Earth. So I want to give some example of these things here. So let me start with the rule of threes. So the rule of threes is that you can survive 3 minutes without air, 3 minutes with 3 hours without a shelter. So assuming it's very cold, very hot, or outside normal body temperature style, 3 days without water, and 3 weeks without food. So that kind of like covers these first 4 elements up there, and that's the ones we consider when we go out in the wilderness, or we get underwater, or we, do adventures here on Earth. But I want to kind of like just give a clip here from the movie The Martian here.
Bjarke, we're not hearing the audio from the
You're not hearing the sound. Okay. So what he was saying, sorry, was just that he was reiterating this thing here. If his water regeneration equipment breaks, he will die of thirst. If his air generation breaks, he will die of, suffocate, and eventually he will run out of food. So if you've seen the movie, it's very much about survival on Mars for this one individual. So let me take another thing that's kind of like going to be important here with Mars here. So my next line I put up is Mars, and you can see there it's getting very fast worse. So we don't have air on Mars. The temperature goes from plus 20 but to minus 200 degrees Celsius. I'm talking Celsius here, so catch yourself a calculator if you are used to imperial notice here. But I think it's around minus 250 degree Fahrenheit. So it's from normal kind of like okay temperature in the daytime or when the sun shines, to so freezing that that you really need to have a highly insulated shelter to survive temperature-wise. I put a little kind of like question mark here about water because we believe there's water, and we're taking pictures from satellites around the Mars that there's water, but we haven't actually had a rover out digging the ground and say this is definitely water. Of course, there's no food, there's radiation. There's nothing that protects us from the radiation. There's also weather, similar to we have on Earth here. There is light because we have an atmosphere on Mars. There's the light here. The gravity is only like 40%, 38%, I think, of the gravity on Earth, which is also a problem. The pressure is like 600 bar versus 100,000 bar on Earth. So it's like not even a percent. Okay, it's I can put it this way: if you are going into space, so if you are like 100 kilometers above Earth, you have a pressure of 10,000 bar. So we have 100,000. So 1% of what we have on ground level, that's 10,000 bar, and on Mars it's only 600 bar. So you need pressure and pressure suits. And it's very interesting because if you take airplanes, for example, they give us 75% of the pressure on Earth inside the cabin when they fly. And outside the cabin is 25%, so quite much more pressure. And they only give us 75 because the airplane can't take the pressure swing when it flies up and down. And that just gives you an example of how much pressure is going to be a problem everywhere else than on Earth here. The regoliths, so that's rocks and pebbles and things like that, or sand, whatever you have on a planet. We call it soil because it have like a carbon elements in it. So it's like we can grow something from the soil. On Mars, the regolith is fine in comparison to other places because it's like sandy and things like that. So we can treat it. It's there. We don't have to bring it. If I can put that, we can use it as building material. It's very toxic for human. It's have a very high concentration of perchloride, so very chlorine rich. So, but since we going outside and we have to have a suit on anyhow, it doesn't really matter. And there's an atmosphere which can come in handy on a later. And yes, we can still generate electricity. And the thing is that I'm going to take a couple of examples here. So this thing here is also from the Martian, and there they facing the storm before they have to go away. And that storm we know is kind of quite realistic. That's the same we see in a sandstorm in deserts like in Sahara and things like that. There is very big storms that's coming in like this thing here, and they are devastating. And that's important to remember, similar to on Earth. We can't predict it. We don't know how much it have an influence. We have the same on Mars. And the reason why this is important is, of course, when I talk about some of the other places we can go to, then we don't necessarily have weather. I also just want to talk about the gravity, the G-force here. This is from a movie called The Space Between Us, where this young gentleman here, he's actually born on Mars. And because the gravity is only 40%, he can't survive going back to Earth. And we are seeing that in, we had astronauts on the International Space Station. And even if they're just up there for a couple of weeks, when they come back to Earth, they have to be lifted out of the module. They're nearly sitting in a wheelchair on the way, and they have to slowly regain the muscle, even though they exercise for several hours on International Space Station every day. So the lack of gravity for us, it's a huge problem. And the thing with pressure, I want to kind of like just have this thing here, which if you've seen the Martian here, so I have these different clips. He had the door here exploding off his habitat, and he's fixing that with this layer of plastic. I don't know about you, but I wouldn't even use that on Earth to make sure I'm not getting cold. So I'm not going to put only that up in front of the windows. And this is something that I have to have him survive with, as I mentioned, minus 150 degrees Celsius and a pressure of nothing really. So this is not going to last anything. And the same with his suit. It's a very tiny suit for a place that can be that cold and have that pressure difference. So I think it's very important to kind of like understand how tough it is, and we don't kind of like romanticize going to Mars or any of these planets without understanding the real numbers behind this thing here. Next one is Moon. And Moon we've been to, and the Moon is even worse. It have one thing that speaks for it. It doesn't have weather. So if we have anything that works on the Moon, it will just keep working. If we leave anything, they will not be covered in a dust storm. If we have a rover, it will keep on driving if it's otherwise is not driving into a crater or anything like that. But the Moon is not going to destroy it. It has a couple of other disadvantages. There's no atmosphere. And because there's no atmosphere, we don't have the light that we know from Earth and from Mars. The light on the Moon is like we have a very strong torch and we walk around in a house. We can only see where the torch points. If there's any kind of place where that torch don't point, it's immediately in darkness. And the same is with the Moon. There is a sun that shines and we can, use it to generate electricity and all that kind of stuff. But if there's a shadow, then it's completely dark. There's not like this softbox light that we have on Earth and we have on Mars that kind of like light up the whole place. So we don't have the light there, and we don't have an atmosphere. So that means that we don't have a gas we can use to anything. Like on Mars, we can consider using the atmosphere. While it's toxic for us, it's great for rockets as fuels. And we don't know if there's water. Similar, we believe there's water, but we haven't actually been there, take it up and see if it actually is water and things like that. So having these in mind, I just want to kind of like again talk about this thing here with human being and how they have to protect themselves. So this is from the movie Gravity, and this represents very much what the uniforms they had when they worked on in the space shuttle program. So they have these very, very, very thick suits on and keep the pressure. And by the way, they're close to the Earth. The temperature is in daytime. So there's a number of other things that's fine. And of course, they get inside the space shuttle as soon as it doesn't work. And we have to look at in comparison to this is the new SpaceX uniforms. And they're only meant to make you survive inside the Dragon model when it flies to the International Space Station. So they're much thinner. This is not the kind of stuff that we can use when we walk around on the Moon or Mars or anything like that. The next one I have up here is an asteroid. And yeah, I took an asteroid separately from the Moon just because we have maybe a feeling of the Moon. But if we could go to the Moon, we could also go to an asteroid, depending on the size. The gravity on the Moon is 16% of Earth. So whatever is bad on Mars is even worse on the Moon. Of course, because there's no atmosphere, there's no pressure at all. On the Moon and on the asteroid, the regolith is very, very damaging. So the dust stays on the Moon. And the reason for that is because there's no atmosphere, there's no weather, there's no wind. Then it's not sanded down. Like, if you go to the beach and you see like a piece of glass that had been lying in the water for many years, it's kind of like rounded down. The same with rocks, the water. They're all like soft in the edges and things like that. And the sand is soft. On the Moon, it's kind of like very finely crusted glass, simply because there hasn't been this wind that move it around. It landed there, it broke into pieces and it hasn't moved. So that is, and because it's very sharp like that, it sticks to everything. So it's very adhesive and it's very bad for moving around there. The astronauts that went to the moon in the 60s and 70s, they had a very big problem with this dust coming into the cabin when I walked in, because it was sticking to everywhere. But otherwise, the moon and asteroids is the same. Gravity obviously is lower, and the asteroids is much further away, so it's going to be difficult to find a candidate there. And then last, I have spacecrafts. So I'm talking about the International Space Station, and I'm talking about any kind of like spacecraft when we move either in orbit, around the moon or Mars, or on Earth, like the International Space Station, or we have a spacecraft that takes us to Mars or to the moon or to an asteroid. That's the worst place. I mean, it's very small. You have no weather. So once the rocket is flying in a certain direction, it just keeps flying. And you can still create electricity, similar to the moon, the Mars, and things like that. And all that is just to kind of like compare with the needs of humankind versus robot. The only thing the robot needs is electricity. We need all the other check marks in order for us to function in space. And that's the reason why robots is so important to kind of like get going with, and why we use them for quite a long time. And I think I just want to add one little thing more. There's been a number of TV series about traveling in space and things like that really have pointed that out, and that is emotions, human emotion. They have like maybe claustrophobia. They can't work because there's not enough light, or they don't get the portion of light they kind of like feel they should have. There are no daylight. They can't open a window. They can't run out. They're missing their families if they go to Mars for a long time. There's all kind of things that a robot just don't have any kind of problems with.